Hello, chemistry students! Today we are going to talk about dilutions. So let's look at these two pictures. The picture here on the left is more concentrated. It has the same number of molecules of a solute. If you notice, we have 6 here on this side and we have 6 here over on this other side. So they have the same number of moles. But the one on the left is more concentrated because it has less solvent than the one on the right. The one on the right has more solvent, so it is less concentrated. The one on the right is more dilute. Now let's look at a dilution problem. Our formula is V1 times M1 is equal to V2 times M2. You can find this on your STAR reference sheet. V1 stands for the initial volume. M1 stands for the initial molarity, V2 stands for the final volume, and M2 the final molarity. What volume of concentrated sulfuric acid, 18 molar, is required to prepare 5 liters of 0.15 molar solution by dilution with water? So we're looking for volume, and it says our molarity is 18 molar. And then we have a second volume, which means I need to start labeling these now. That's V1 and M1. Our second volume, our final volume, is what we're going to prepare. And our final volume is 5 liters. And our final molarity needs to be 0.15 molar. Now we're going to use this formula and just plug it in. So V1 is what we're looking for, so I'm going to keep that. Multiplied by M1, which is 18 molar, is equal to V2, which is 5.00 liters, times M2, which is 0.150 molar. I need to get V1 all by itself. I need to move 18 over to the other side. So I'm going to look at the relationship between these two numbers, and they are multiplied, so I'm going to do the opposite, which is divide. Whatever I do to one side, I have to do to the other. And I'm going to divide by 18. My 18 molars go away. My molarity here, I've got a molarity on top and a molarity on bottom, so they go away. And the only units I'm left with is liters. So my V1 is going to equal 5 times 0.150 divided by 18, which is 0.042 liters. Now I'd like for you to pause the video and complete the next 3 practice problems that are in your notes, and then come back and check your answers. These are the answers for 1, 2, and 3. If you did not get the correct answer, watch the rest of the video for the explanations. A chemist starts with 50 milliliters of a 0.4 molar NaCl solution and dilutes it to 1,000 milliliters. What is the concentration of the sodium chloride in the new solution? This first one, 50 milliliters, that is a volume, and it is V1. And our initial molarity is 0.4 molar. We are diluting it, that's the new volume, to 1,000 milliliters. We are starting out with 50 milliliters, and now we're diluting it to 1,000. Adding some water, and we need to know what the final concentration is. So here are our variables. We know that our formula is V1 times M1 is equal to V2 times M2. I'm going to rearrange my formula to look like M2 equals, which means since these two are multiplied together, the V2 times the M2, I need to do the opposite, which is divide. And I need to move the V2 to the other side of the formula. So I'm going to divide by V2. My V2s, I got 1 on top, 1 on bottom. V2 divided by V2 is 1. So my new formula that I'm going to use is M2 is equal to the initial volume times the initial molarity divided by the final volume. Now I'm just going to plug all these in. M2 is equal to 50 milliliters times my initial molarity, which is 0.40 molar, divided by my final volume, which is 1,000 milliliters. I'm going to cancel my units. I have a milliliter on top divided by a milliliter on bottom. They go away. My final molarity is 50 times 0.4 divided by 1,000, and my units are in M. So that is 0.020 molar. Number 2, a chemist wants to make 500 milliliters of 0.050 molar hydrochloric acid by diluting a 6 molar hydrochloric acid solution. How much of that solution should be used? So let's talk about our variables. We have 500 milliliters, and he says a chemist wants to make that much. So that is our final volume, 500 milliliters of 0.05 molar HCl solution. So that is our final molarity. By diluting a 6 molar solution. So that is our initial molarity, is 6 molar. How much of that solution should be used? So that is our initial volume. We need to find out how much of the original solution, M1, do we need to use to dilute it to make 500 milliliters. So now let's plug this in. Our formula is V1 times M1 is equal to V2 times M2. I want to rearrange my formula to look like V1 equals. So I come over here, I find my V1. It is multiplied by M1, so I do the opposite, and I divide by the variable that I want to move to the other side, which is M1. M1 divided by M1 is 1, so they cancel. And my new formula is V1 is equal to V2 times M2 divided by M1. Now I'm going to plug that in. V2 is 500 milliliters. M2 is 0.05 molar. And M1 is 6 molar. I have a molarity on top and a molarity on bottom, so they go away. And my new volume is 500 times 0.05 divided by 6, which is 4.17, and my units, or what I have left over, is milliliters. So I need 4.17 milliliters of a 6 molar solution, and then add enough water to make a total volume of 500 milliliters to get a 0.05 molar solution. How much 2 molar sodium chloride solution would you need to make 250 milliliters of a 0.15 molar NaCl solution? 2.0 m, that is a molarity. And then it says how much, so that's a volume. Initial, because it says how much of this would you need to make. 250 milliliters would be our final volume, and 0.15 molar is our final molarity. So V1 is what we're looking for. M1 is 2.0 molar. V2 is what we're making, 250 milliliters. And M2 is the concentration of what we're making, which is 0.15 molar. Our formula is V1 times M1 is equal to V2 times M2. I need to rearrange it to look like V1 equals. So I look for my variable, V1, and it is multiplied by M1, so I have to do the opposite, which is divide. And I want to move the M1 to the other side, so I divide by M1. M1 divided by M1 is 1, so they go away, they cancel. And I'm left with V1 is equal to V2 times M2 divided by M1. I'm just going to plug those in. Volume 2 is 250 milliliters times M2, which is 0.15 molar, divided by M1, which is 2 molar. I'm going to cancel my units. I have a molarity on top and a molarity on bottom, so they go away. I have a milliliter on top, but I don't have a milliliter on bottom, so it does not cancel. 250 times 0.15 divided by 2 is 18.75, and my units are what I'm left with, milliliters. I need 18.75 mils of a 2 molar solution, and then dilute it with water, add enough water to make 250 milliliters, and that will give me a 0.15 molar solution. Thanks for watching.